So if you want to execute a HDL based programs, you need a tool called Xilinx ISE 14.7. So you have to install that tool prior to this task. So just to open the tool, just to go to the start button, and in that there is a folder called Xilinx design tool. So in that there is a option called the 64-bit project navigator. Just to click it. So if you click it means, so there is a window will open. So initially it will show some tips. So that is not required as of now. Just to close it. Okay. So this is what the Xilinx ISE window. And before starting that, you have to create a project. So for that, you just go to File, and there is an option called New Project. Just to click it. And after that, you have to mention the project name. So here I'm just to mention the name as Shakti. And don't forget, one important thing is the project location is not be in C colon. Okay, so you have to choose the project location as not in the C colon, that is a D colon, E colon. So anywhere you can choose it, but C is not permitted. So it is already in the D colon, so no issues. And then click next, next, and finish. So if you finish it means, so there is a created project here. You can see Shakti. Okay, so after creating the project, after created the project, so next you have to create a new source. So for that, there is an option here. That is under the file. There is one paper is that one logo is that. Just to click it. Sorry, under the design there is one small logo will be there. There is a logo called new source. Just to click it. Okay, so in that several options will be there. So now we are going to write a program in Verilog module, so that we have to choose the Verilog module option. And then now I'm going to do a program for UndK. So for that you have to create a name, that is UndG. So don't forget, you have to choose Verilog module, then you have to mention the file name, and then click next, next, finish. So then the window will appear like this only. Okay, so here you have to click it, and you have to press Control Alt and then delete it. So in this window you have to write a program. So okay, so now I'm going to write a program for UndGate. So that is module. So the program name and open bracket, and the output comma input, that is A comma B comma C. So A and B is the input and C is the output, and close bracket and semicolon. And the next line you have to mention the inputs. So input A comma B semicolon. Next you have to mention the output and C semicolon. And so module is mentioned and input and output is mentioned. And next you have to mention the body of the program, that is and you have to mention the gate name as G1 and open bracket. So here you have to mention output comma input, not input comma output. That is the output is C comma A comma B. That is C is the output and A comma B is the input, and close bracket and semicolon and enter. And here you have to mention end module. So don't forget, end module doesn't have there is no need to mention the semicolon in the end module, and also there is no space in between the end and module. And once you return the program, so you have to save it. So there is an option here, save. Just to save it. Okay, once you save it, you have to check the error. That is, we have to compile the program. So for that, there is an option called synthesis XST. Here there is an option. Okay, so in that, just double click it. Make a double click. So it will make some rotation. So depends on the program, it will take some time. And if we in our program there is no error means there is some green color tick mark will be there. If we have error means there is some red color into mark will be there. See here, there is a green color tick mark, so that means we don't have a error in our program. So so that means we will proceed further. Okay, So before proceeding further, first we have to check the RTL schematic diagram. So that means, so now we wrote the program and through the program we just retrieve the diagram. So that is what RTL schematic. So there is an option under the synthesis XST, view RTL schematic. So how this option will be there means, so there is a plus mark in the synthesis XST. So you have to click the plus mark now. So there is some sub options will be available. So in that there is an option called view RTL schematic. Just to make a double click. And in that you have to choose the second option, that is start with a schematic of the top level block. Then click OK. So if you click OK means it will show the block diagram, and inside the block you just move your mouse pointer and make a double click. So now you can see we have the AND gate. Okay, so through the coding we can get the diagram. Okay, so this is what RTL schematic. So this is the first output. Okay, so in the observation you have to take a screenshot of this and you have to paste this output. Okay, next we have to get the simulation waveform. So for that, what is the next process means? Okay, so here again you have to click the new source. Okay, again you can see under the design there is an option new source. Just click it. Okay, and then you have to mention the name. Already we mentioned the name as AND-G. So very important point is you have to include underscores DB. Okay, so DB stands for test bench. Okay, so you have to mention the same name as we mentioned earlier, and inclusion with that you have to mention underscores DB. And one more important thing, so now you have to choose Verilog test fixture. Okay, priorly we choose an Verilog module, so now we choose Verilog test fixture. And don't forget you have to given the name like this only, that is the same name already we mentioned and underscores DB. DB stands for test bench. Then click next, finish. Okay, so now you can see there is some program. Okay, this is what the test bench program. Okay, now by default it having a single input, that is A is equal to 0 and B is equal to 0. So we have to given the other inputs. For example, AND gate we have it's a 2-bit gate, that is A and B is the input. We have 4 different inputs will be there for AND gate. I hope you know that is 0 0 0 1 1 0 and 1 1. Okay, but in the test bench program only we have 0 0 input alone. Okay, so for that how we can elaborate the program now, just to make a copy. Okay, that is from A is equal to 0 to hash 100. Okay, so just to select this and control C and click enter here and control V. Okay, so control V, and you have to press control V for 3 times because we have to create 3 more inputs, no? So that is the reason. Okay, now you can see, so the first input is A is equal to 0 and B is equal to 0, and the second input is A is equal to 0, and here you have to change the B from 0 to 1. That means 0 and 1, and the third input 1 and 0. Here you can change the A from 0 to 1, and for the fourth, so 1 and 1, so that means you have to change both A and B from 0 to 1. So here I just to erase the 0 and enter 1. Okay, so now the test bench program is ready. Okay, so once you typed all the things, okay, so again you have to press the save button. So you can see here under the edit there is a save option. Just to save it. Okay, so after that we have to change one important thing, that is from here you can see view layer. So there is option implementation is already clicked. Okay, so you have to click the simulation button here. Okay, so once you click the simulation now, okay, so now you can see in the under the project our recent test bench program will be there, no? So that file name will be available here. Just click this. Okay, so once you click it now, so there is one more option will be enabled, so that is called ISIM simulator. Okay, so in this there is a plus mark. Okay, just click the plus mark. If you click the plus mark now, there is 2 option will be there, that is behavioral check index and simulate behavioral model. First you have to click the behavioral check index. Okay, if any error is there, it will intimate. So here there is no error, so that is why we received the green color tick mark. So the next option is simulate behavioral model. Just to make a double click in that. Okay, if you made double click means so there is one simulation window will appear. So from here only we can get our output. Okay, so you can see there is a run button here. Okay, just click it. Okay, once you click it, there is no changes. Okay, so but don't worry. Okay, there is one more option called zoom out. Here you can see there is a minus lens will be there. Just to make a click again and again. Okay, you have to click up to when the output will come. Okay, you can see here the output will come. Yeah, so this is what the output you can see in the waveform. If it is if it is a downside means it will it means 0, and if it is upside mean it will it is a 1. Okay, so you can see the first input is 0 and 0 means the output will be 0. So that is indicate both input will be 1 and output will be 1. Okay, so any one input will be 1 and output is 0 okay, so you can see the last time you can see, so A is 1 and B is 1 and the C is 1. That means output is 1. Okay, this is what the second output. So the first output is RTL schematic. So you have to take the screenshot of RTL schematic and you have to paste it in the observation. And this is what the second output. So again, you have to take a screenshot of this and you have to make a printout and paste it in the observation, right? So this is what the simulation output. Okay, so in the both the lab, that is both digital lab and VLSI lab, for some experiments you have to complete the procedure up to this. But for some additional experiments having some analysis based experiments, you have to do some extra work in the same program. Okay, now we will see that also. Okay, so for that just click just click here. Okay, so click here again here, and you have to change it to implementation again. And that is in the analysis lab, we are going to make analysis of area, delay and power. That is in the simulation base lab, we just get the output of RTL schematic and then the waveform output. Okay, and for the analysis operation lab, we are going to measure the area, delay and power, right? Okay, so we'll see one by one. So for that, so there is a after synthesis XST, there is one more option called implement design. So you have to make a double click this. So it will make some rotation. So depends on the program, it will take some time. So please wait. Okay, so if you click the plus symbol in the implement design now, so there is some sub options will be there. So we'll see one by one. That is the area, delay and power. Okay, it will complete one by one. So the first option translate is completed, and the second option map is completed, and third option is running. That is place and route. So once we completed the entire thing now, so we can able to see the entire report. That is area analysis, delay analysis, and power analysis. We'll see one by one. So during the processing time, you just click here. There is an option called a design summary. Okay, just click in this. And you can see here there is an option called a synthesis report. So from this only we are going to see the area and delay. And for the power, there is one more option called place and route. So in that we are going to see the power. Okay. So now the entire process is processing is over. So now we just click the synthesis report just to make a double click. So in the synthesis report, so you can just scroll down. So if you scroll down means we can able to see the area, delay and power. Okay. So I hope you can see. So this is what the area analysis. You can see. So the number of slice LUTs, number of user logic, number of LUT flip-flops, number of IOBs. Okay. So this is what the area analysis. That means you can see out of 63,400 LUTs, we are using only one. Okay, so that means we are using only 0%. Okay, so 0 means 0.001, some percentage will be there. So likewise, we analyze the area. So this is what the area analysis, right? And for the delay, again, you have to scroll down further. You can see here there is a delay. So you can see, so total time is equal to 0.757 nanosecond. So this is what the delay analysis. Otherwise, you can see here also the total real time to complete and total CPU time to complete. That is real time to complete is 11 second, and for the CPU time to complete is 11.66 second. Okay, so as of now we discussed about the area analysis and delay analysis, and the remaining one parameter is the power analysis. So for the power analysis, how we can see the power analysis now? So from the implement design lab, there is a plus mark, just click it, and from that there is an option called place and route. Okay, so in that also there is a plus mark. Okay, if you click the place and route plus mark now, so there is one option called analyze power distribution, that is X power analyzer. Just to make a double click. Sorry. So now we can see the power analysis also. It will take some time, so kindly wait. Yeah, I hope you can see the power analysis. Yeah, you can see the supply power. Total power is 0.082, and from that the dynamic power is 0 and the coefficient power is 0.082. So this is what the power required to design the AND gate. Okay, so this is how we can able to see the area analysis, delay analysis, and power analysis. Since I already told you, for some experiments up to simulation waveform we are going to do, and for some extra experiment, that is after the 10th experiment, some experiments having the word called analyze the following program using Xilinx ISE. So likewise if they are asking the question now, so you have to do up to this, that is you have to make the area, delay, and power analysis. Okay, so wherever you want, you just take a screenshot and take a printout and paste it in your observation. So thank you. I hope you can now understand the tutorial of Xilinx ISE 14.7. So in case if you are having any doubts, please mention it in the comments. I will clarify it. Thank you. Thank you so much.